All right, a problem was posed on Friday. I put on the blog about Presley and Anthony, and I want to go ahead and work through that problem with you now. Forgive the shaky camera, working from my iPhone, which was not the intended plan, but I wanted to get the vlog up for you guys anyway, so here we go. All right, let me read through this problem, and we'll go ahead and tackle it together. Presley has 18 markers. Her teacher gives her 3 boxes and asks her to put an equal number of markers in each box. Anthony has 18 markers. His teacher wants him to put 3 markers in each box until he is out of markers. First question says, or the first item says, before you figure out what students should do, answer these questions. What is happening in these two situations? How are they similar? How are they different? And then number 2 says, figure out how many markers Presley should put in each box. Show your work. Then, figure out how many boxes Anthony should fill with markers. Show your work. Okay, so let's do number 1. Let's go in chronological order here. What's happening in these two situations? How are they similar? How are they different? All right, well, we've got 2 kids, and they've each got 18 markers. All right, there we go. There's something that's similar. Let's see, can you find something else that is similar? I'll give you a moment to look it over again. They're similar in that they're dividing up these 18 markers somehow into boxes. That's a similarity, right? And then there's also the presence of the number 3. It's another thing that's similar. How are they different? I'll give you a moment to look at it and think. You might have noticed that one of the differences is where the 3 is located. So when we look at Presley's situation here, Presley has 3 boxes, whereas Anthony, the 3 is attached to the 3 markers. So we're going to kind of look at this division problem through these 2 scenarios. And first let's talk about Presley. I went ahead, I would like to introduce you today to some manipulatives. Ta-da! These are called multi-link cubes. They are a classroom staple. Hopefully your kids have seen them before if you haven't. And they're really great manipulative for thinking about concrete, making numbers a little bit more concrete. Numbers that can sometimes be abstract, making them a little bit more concrete. Okay, so I counted out 18. So these are going to represent our 18 markers, each of these. And we're going to go ahead and do what Presley had. So Presley's teacher gave her 3 boxes. So I gave us, B1, B2, and B3. And we're just going to go ahead and take the 18 markers. There they are. And let's see, 1 for you, and 1 for you, and 1 for you. And then we're going to keep doing that. Do-do-do-do, do-do-do-do, do-do-do-do. And this is, you might hear in a classroom, you might hear this referred to as fair share. Or you might see in textbooks the idea of dealing. I'm dealing out the markers right now so that it's even, kind of like in poker. Although poker is probably not a context that we often think about in elementary classrooms. Okay, and there, I've gotten them all. So if we look at them and if we can arrange them into nice little even rows here, the great thing about these multi-link cubes is that they do click together, and my intent was to click them together for you, but now that I'm playing camera woman and math teacher at the same time, I only have one hand, so we're going to just go with it. So here we go. We put them all together. They're even. We can see that because they're nicely lined up, and then we can count here. 1, 2, 3, 4, 5, 6. We've got 6 there. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so Presley has her 3 boxes each have 6 markers, and she was able to achieve her goal. Okay, so let's think about that context. I'm going to go ahead and slide these guys out of the way just so that we can think about Anthony and what Anthony's situation, how it's similar but a little bit different to Presley's. Okay, so here's her 3 boxes. Still, okay, and here's Presley. Presley's green. So again, 18 markers. But here's the different content of the context. Okay, so Anthony, his teacher wants him to put 3 markers in each box until he's out of boxes. Until he's out of markers. So we don't know how many boxes, but we know that each one gets 3. They can only fit 3, let's say. let's put that nice little constraint. So I'm going to go ahead and take 3 out, and there's 1 box. Okay, so then I'll go ahead and grab 3 more, and there's another box. Ta-da. Okay, so making my boxes. There's another one, got 3 boxes, another where I've got 3, that makes a box. That's 4 boxes we've got now. Let me zoom out a little so you can see that I'm dealing with all of these. 3 there, and okay, and that's all of them. I've got empty containers. Ta-da. So, with Anthony's situation, I have, let's see how many boxes we ended up with. 1 box of 3, 2, 3, 4, 5, 6. I ended up with 6 boxes. Okay, so we're kind of answering number 2 here as we're going. The first part of that was figure out how many markers Presley should put in each box. So if we go back to Presley's situation, 1, 2, 3, 4, 5, 6, 6 go in each box. That was what we had to find out. And then we also had to figure out how many boxes Anthony should fill with markers. And how many boxes are there? 1, 2, 3, 4, 5, 6. Okay, so in both situations the answer is 6, but let's think about this for a moment. In Presley's situation, the answer is 6 markers per box, right? Because we had 3 boxes to start with. And then in Anthony's situation, the answer is 6 boxes, because we weren't sure how many boxes we were, excuse me, it's off the screen there. Okay, so 6 boxes, we weren't sure how many. So the answer is 6, but there's slightly different contexts. All right, and that answers the question, the task question. But what I want to underline for you right now as parents, as adults, is I want you to notice something here. We had 18, right? And we know that 18 times 3 is 6. That's kind of the context here. And if I divide 18 by 3, I get 6. But there are 2 ways of thinking about that. Let's see if I can kind of make this a little bit obvious by giving a little bit of space. In one scenario, I've got 3 sets of 6, and in the other scenario, I've got 6 sets of 3. Same quantity, and as we said before, the answers are the same, right? We got a 6, we got a 6. But it's not exactly the same, and what we did to get there was not the same. Remember here, we had to go 1 for you, 1 for you, 1 for you. And then back to that same person, 1 for you, 1 for you, 1 for you. We had to deal out, we had to do the fair share. And here, we didn't know how many people we were dealing. So we kind of just had to partition out 1 set of 3, 2 sets of 3, 3 sets of 3, 4 sets of 3, and do it that way. Or you might say groups of 3. Groups, sets, these are words that often get used in the classroom. So these are just 2 different ways of looking at division and 2 ways of thinking about the way that the operation happens. And this problem is set up to ask students, well, not really ask them, but to underline that, to show them that there's different things that are happening with our hands as we physically touch objects and think about how division happens. Even though our answer might be the same, even if I kind of take this and I make it very, very abstract, and I say, you know what, we don't know anything about context, we just need to know 18 divided by 3 equals what? If we take out all of the context, we could say, well, that is just 6, right? We know that. But in these 2 cases, it's 6 what? 6 markers per box, and how do we get there? Through a fair share. Or 6 boxes, and how do we get there? By repeatedly breaking out sets of 3. So there's just something to think about. This is an example of a very rich task that asks students to really look closely at the operation of division and to think about different strategies and how those strategies in some contexts might be important. In this context is very important. In some contexts like this, maybe not so important. That's okay. It doesn't always have to be important for us to learn it. What's important is that we understand division in a rich way so that when it is important, we can identify that importance. Hopefully this was helpful. Hopefully you like it, and hopefully next time you'll feel comfortable to share some thoughts. All right, thanks for listening.